Good morning, everyone. How are we? Thank you all for coming down this morning. It's a little bit early and it's quite a little miserable day with this drizzle starting to come in, but I think it's going to get a little bit better. This is a bit of an impromptu event leading into Christmas, and I'd like to thank the UQ team with Ross and his fellow associates here. They've agreed to come down, and they've got a robotics and automation conference to get back to straight after this. So a big effort for them. Thank you. I guess I'll start off with a little bit of housekeeping. So toilets, if you haven't found them yet, down this aisle here. If there's a door there, go straight through and go to the end. Male and female both down there. If there's any sort of whoop whoop, beep beep, downstairs and to the right. Apart from that, I hope you've all got your coffees and your juices and whatnot should be coming around. And breakfast will be getting served while the presentation is happening. So introducing Ross. So Ross is, he's the head of school for the mechanical and mining at UQ. He's got 20 years at UQ in various type roles, but his current focus is in the machine automation space. So he's going to be outlining the changes to the UQ mining engineering course. So yeah, welcome Ross, and looking forward to it. Thank you.
Thanks, Andrew, for the introduction. I was thinking just last night, we've overlooked that 2020 was a leap year. If you think back, February had 29 days, March had 55, April 270. It really does seem like a very, very long year. And it's been one that's been quite tumultuous for the university in terms of changes to our student profile, the loss of international students, something which we expect to see, legislation that's been brought in by the Commonwealth, which changes the way in which we're funded, not to our advantage, and the exercise that I've been talking about here, which is some reform that we are making broadly to our engineering programs and specifically to mining engineering and the way we deliver it. So with my comments about this being a year that seems to have been drawn out, I guess if what I talk about now appears to drone on, I'm going to use that as my single defence. So I'm the head of the School of Mechanical and Mining Engineering, which is much broader than mechanical engineering and mining engineering. It's materials engineering, mechatronic engineering, aerospace engineering, and I'm sure I've forgotten one of them in there, manufacturing as well. But I'm also representing, in a sense, the School of Civil Engineering and the Sustainable Minerals Institute, who also have an important role in the in mining engineering education at the university, and increasingly so going forward. The real strength of UQ is its comprehensiveness. Maybe this is something we've not fully appreciated in the past, but something that I believe we now have a very clear vision with. So my colleagues today are Alice Clark from the Sustainable Minerals Institute. Many of you will know Alice as a former president of the AusIMM. And you may have seen her mentioned in the media in the last week as she was made a fellow of the Academy of Technological Sciences and Engineering. Cormac Murphy is the faculty's engagement manager, and some of you may know Cormac. He had a previous life recruiting into the mining sector, and he has an excellent address book. I've been leveraging it, but if anybody else wants to leverage it, he seems quite open to do that. But what I'm going to talk about is something we've spoken to at various fora. We've engaged with various companies, and it explains what we're trying to do with mining engineering and the broader context for it. And I'll just see if I can progress the slides. So I'll just give you a bit of a view of the current state. And at the moment, we offer a pathway in our Bachelor of Engineering program for mining engineering. And this is our primary pathway for graduating mining engineers. It's a 4-year degree. I'll give you some numbers here. They may help later. 64 units of study. Typically, students take 2-unit courses, so that's 32 courses or subjects. And of these, around about 30 units or 2 years of the program builds foundation engineering knowledge, and the balance builds an understanding of mining engineering. I think a number of people here have gone through that program in recent years. Is that right? Show of hands. So I'm speaking to the preaching to the converted in a sense. You're familiar with it. You've experienced it. I'll get the hang of this computer shortly. And students will elect to enter mining at the end of year 1. That's formally. Some people come in know exactly what they want to do. Others make their choice during the first year and execute it. At present, we typically have a small number, 10 to 15 per year over the last few years. And this is problematic. And this has driven us to look at change. This is a quite sensitive computer if I push there. All right. So we're a business, we're like any other business, and we have to deliver value to our stakeholders, and our stakeholders are our students and the industries they enter into. And at present, and for the last 6 or so years, it's been costing us approximately $1 million more per annum to run the program than we generate as revenue. And this is problematic for a couple of reasons, and it becomes more problematic going forward as our funding reduces and students are being asked to pay more. We make up that balance by stealing from other student programs to cover the costs. And as you can imagine, in any culture where there's inequities, some people feel dispossessed, and it's important that we try to balance it. We're also not meeting enough graduates to satisfy the industry. We have some chronic problems in this respect, certainly within the university. Many organisations have come to us and offered scholarships and similar for students who are graduating or in the third year, second and third year, fourth year of their programs. We're simply not able to fill those scholarships. One of Cormac's roles is to do this, and it's a significant challenge to him. But this is a symptom of something much bigger, that we're just not attracting enough students into the mining program for it to be in any way useful to our industry stakeholding group. And we have this interesting dynamic where across other plans of engineering, many of our graduates do look to enter the mining sector. And so this is particularly true of mechanical and civil engineering. So mechanical engineers have always had a pathway through asset management and the like, maintenance roles and similar. But at present, they don't get any schooling at all in the industry and how it generates value and the principles underlining it. We see that as a gap. And civil engineers, I think, have in many cases been taken on to essentially mining engineering roles, and they have a set of skills that allow them to do that, but we're not convinced that they meet those requirements fully either. So there's a bunch of systemic issues that exist in this space that we're trying to, and we have a further complication in this, and that is the way we've structured ourselves. We're unable to take people who might want to transition from other roles into, I'll call them essentially mining engineering focused roles or resource engineering roles. So this is for us a challenge without that pathway. And so we've been looking to address these things. I'm told there are many geologists who want this route. Is that right, Alice? Okay. I haven't seen the evidence of that, but okay. So look, we've tried to bring some reform. We're bringing reform to what for the university has been a systemic problem for many decades, probably since the program began. It's a boom and bust industry, and we seem to be always out of fame with the boom and the bust. So when we've got lots of graduates, there are no jobs for them, and when we've got no graduates, there's a lot of demand for them. But the last 7 years has seen something quite different, and that is a strong reluctance for undergraduates to enter this plan, and that is something that we're very concerned about. And so the changes that we're going to bring in, and I'm going to describe them, are intended to address that. We did in 2019, we convened a committee. The committee was chaired initially by Michael Hood and then by David Overall. Some of you may know those two characters. Michael Hood was a former CEO of a CRC in mining. David Overall was former, well, he had a long career in BHP, but a former CEO of Downer Mining. And we assembled a group of industry people around them. We looked to get some fairly high-level representation. Charlie Sartain was there. Ian McFarlane from the Queensland Resources Council sat on it. And I'd probably need to go back and look at the list, but it was a quite high-level group, and the idea was we would use this group and their connections to reach out into industry to help us address some of the questions that we had. And as part of this process, we built up a straw man model and said, look, if we were going to change, what do you think of this as a mode for change? And had a model that was fairly easy to describe to them in a short time, not very well detailed, but enough to stimulate discussions. And a number of companies looked at the model and said, yeah, that's a great model. We like that. And other groups said, oh, come on, you can go further. And we encourage you to do so, be radical. A lot of, and this was very rewarding. Many companies told us they liked our graduates. So those who graduated from the program, you're valued for your knowledge and skills broadly by some of the industry's leaders. And they say that without emphasis. They expressed a need, I guess, for more emphasis on modern analytical tools. And one of the drivers for this, and Andrew, you probably won't like me saying it, was they didn't like to have a reliance on groups. They preferred an in-house capability, but we figure we're agnostic to that. But that was one of the things that came through. So how do we build a geotech team internally, and how do we build a team of people who are skilled in strong analytical methods? But overall, I think there was a strong need for change, and it was acknowledged. This was happening around the time the Minerals Council pulled out of any funding for universities. They had helped us sustain for a period through what was known as the MEA program, but they removed that support, and all of the pointers were we need to do something different. And so we've taken a view at UQ that we want to be the leading resources university in the nation, and we want a position for that to serve the industry, to serve our students, and of course to benefit ourselves. We conducted a survey of our students as well along this time, and interviewed many of them through a focus group company that we brought in to have a chat. And we get normally about 30 to 40% of the student body. So in real numbers, that's about 300 to 450 students, depending on the year, and overall about 1,200 students who were invited to participate around this. The response rates were disturbingly low against real numbers, and disturbingly low against other exercises we've done here. And we took from that a message that there's a general disconnect of the student body with, I guess, the general resources engineering field, and that reflects in numbers. Our group really divided itself into two cohorts. There was the first and second year students, and those that did respond conveyed that they didn't see mining as a bad option. They just felt they had better options and expressed a desire for flexibility. And that flexibility was, I guess, insurance in the main sense against losing options. And so we found that they were arguing for more general programs over and choosing more general programs over mining engineering. There was a sort of reluctance by them expressed to commit to an industry that they perceived as having more social capital. So, you know, how would they justify to their friends that they were studying mining when their friends were perhaps not naturally interested in that area, or may have even been negative towards them. And they held some other perceptions which for them were very real, but of course aren't true. That if they did mining, they'd end up spending their career in remote locations, and they'd grow old and lonely up in the bush somewhere. And it's an issue, but it does speak to, I guess, a real misalignment between the industries and the values of people who are in their early 20s, late teens and early 20s, who are making these decisions. Our third and fourth year students were more pragmatic, and I guess if you think back to when you were about to graduate, one of your concerns was, well, what's my next step? Where do I go? What's my move? Can I get a job? And here is really strong enthusiasm for mining engineering as a discipline, and a really very strong interest among graduates to enter the resources sector generally from across various engineering plans. I kept a tally, and I looked at it this morning, of the number of references I wrote for students who are looking to enter resources companies or seeking to take on graduate programs. And this year, there are 107 references I wrote in that. Many of them may have been a bit similar, but they were nevertheless a very strong interest in that sector. So that's something that's really tangible, something we need to work with. I'll say this, all students at all levels are interested in work experience and work integrated learning opportunities. The QRC program, where first years are able to do their vacation or mid-year break in an industrial context and mining context, very high interest in that. And it has helped us recruit some students, but the numbers are still low, and we get about a 20% yield out of that program, but into the mining plan. But we do see students being very interested in work integrated learning. So that's the sort of background and context to all of this. This year we set ourselves the task of looking at how we would develop curriculum, and there's a little bit of background to this, which is our engineering curriculum review, which started. This will be introduced in 2021. And what that means is students who are currently in year 12, or maybe previously studied year 12 but didn't enter university, who enter the university next year will work in the new engineering plan. And those who are currently in first year may elect into mining in second year, and they'll follow through. And so there's a pipeline that exists. So we have a little bit of time to get this right, and we're going to take the time, and we're going to do it well, but I'm going to give you an update on where we are and opportunities for you to engage in this. The new plan will have a common core of eight courses in the first year. These will be 2 engineering courses. One of them will be a programming course for engineering. Another will be an introduction to engineering. And there are 2 mathematics courses, and these form what we call our common core of 8 units. Some students come to us without prerequisites, and so they need a chance to catch up. and they will do so. We've reserved I guess 2 courses or 4 units for those students, and then for the balance, or if they don't need to catch up, they move into one of a number of specialisations. I realise I've left off one of those specialisations, and potentially it's relevant. So a specialisation in mechanical engineering, electrical engineering, chemical engineering, mechatronic engineering, civil engineering, or software engineering. Okay, so students will elect into those, and they will basically occupy 36 units of their studies. So if you think about that in terms, that's 2 and a bit years. However, they aren't truly specialisations only in those areas. They build a number of attributes that are generic and common, and there's some more maths, engineering science, which is foundational, usually taken in year 2 or sometimes in year 3, some specialisation, and an emphasis on design. Now, the balance of units, 16 units, which I've shown here living in the 4th year, are for a major. That could be a major in the specialisation, double major. It could be for a minor. You might like to do some language studies or similar, or it could be a major in one of our key areas. And so in the school, the majors will be in aerospace engineering, manufacturing, materials, and mining. And so 16 units, and you will see immediately that we've dropped in the BE the number of units available to students. But what we have done through this is opened up a pathway for more students to access these mining courses. And I will speak to how we're addressing that imbalance later. And so that major will be available to civil, mechanical and mechatronic engineering students, those who choose those plans. The major looks a little bit like this. It covers 2 aspects, two core themes. One is, I guess, the foundations. So getting an understanding of geomechanics and you know, rock mass and how it's described and why it's important. There's mining systems, of course. So development and infrastructure of mining, the equipment that's used and the methods that are used in surface and underground at a hopefully sufficiently level of depth to allow people to get a good feel for this. And then there's mine planning. These 4 mine foundation courses. We're also looking to build a knowledge of the value chain. So ore body knowledge and how it's used, mine geology, you know, the role of prospecting and exploration, geometallurgy, getting students to understand that, you know, the ore body and why it is so important, mine design and feasibility, which builds from that, and then mine process optimization. And we believe that these 6 courses will enable our students to get a sense of how the mining industry works. They're not going to come out with all of the skills that you would have come out with as mining engineers, if that was your route, but it will better position civil engineers who take on roles and mechanical engineers and mechatronic engineers to be able to work within the frameworks of the industry. And I'm going to talk a little later about how we're going to cover the gap between this and what's there. I'll just summarise another point though, and that is, in doing this, we've tried to provide flexibility. So I showed initially that a student may take the major in the final year, and that is one of the options, but we think it's better if they start earlier. And so knowing that come 1st and 2nd year, they're not so interested in general, we've configured it so that come 3rd year, it's available to them as a choice. They can still delay to 4th year if they want, but they can opt in early. And we know there are some students, and it's only a handful, that are going to want to start doing this right up front from their first year. And perhaps I'm sorry for my ineptitude in operating this computer. The mouse or touchpad is not behaving. Yeah. How do I present again? Normally I'll just push that.
Yep. And
Okay. Not from the beginning. All right. So I'll let you read these words. I'm not going to try and do it, but we're imagining that there's a family of, I guess we'll call them resources engineers, who have a specialisation in a discipline that's relevant to the industry, and a major in a set of, I guess, in the industry. And for those students, it gives them flexibility to either behave or find employment within or beyond the sector. And they will be slightly specialised. I haven't got a capability statement in this slide deck for our mechatronic engineers, but it's there. There's a trick to this, and it's not just pushing this button. All right, those slides are out of order. Here's the case for a student who might want to enter this in first year. And so they would have the option of taking a course essentially in every semester of their studies. And we know there will be students in this category, and we know there are organisations who would like to identify these students and bring them into their own cadetship programs to help them essentially recruit talent by developing and identifying and developing it during their studies. And so there's that as a theme for this. I'll just, this might be too hard to read in too much detail for this forum, but there's a typical study plan. We think for a civil engineer with a major in mining, and the colouring follows that set of ideas. So those common first year courses, there may be some electives. They'll have some other courses they need to take. You'll see there's a development, as is general in all civil engineering programs, around geotechnical, and there's option to take the geotechnical subjects within the major. So advanced rock mechanics and hydrology, as well as the 6 courses that I've identified. Similarly, for the mechanical plan, we've configured this one slightly differently, and there are other ways of arranging it, of course, but we'd be looking to have here students finding their entry if they chose to take this study plan in third year, which is where we see a lot of interest from mechanical engineers looking to find their future, and so those 6 courses would appear in the final 3 years. 3 semesters of their study. So just to summarise, we envisage the graduates from this new program who take the major in mining will form a corpus of next generation resources engineers. They'll have a core engineering specialisation. They'll be civil, mechanical or mechatronic. They'll have an understanding of mining and the mining value chain, and they'll be capable of contributing practical and principled engineering effort to their employers. We see that they'll have a broad set of paths. They'll be able to work for mining companies, they'll be able to work for equipment manufacturers, they'll be able to work for mining technology providers, and I would say MEC is in this area in certain respects, or in consulting groups. And importantly, we anticipate that this will attract 60 to 100 students per year, and this number will be regulated by demand and give flexibility for students to delay their decision making, which is a critical element for bringing in a good number of students. Okay. However, we also acknowledge that we've lost something, and we want to ensure that we provide a pathway to deliver that. And for this reason, we're going to leverage the university's existing program, which is the Bachelor of Engineering, Master of Engineering program. This is an integrated degree. Students who take on this in the mining area will graduate with a Bachelor of Engineering in their specialisation and a Master of Engineering in mining. And of course, they will need the major in the bachelor's program. Structurally, it's similar. There's a common first year, the same as that, and the specialisation and the major, which could be configured a number of different ways. In the 5th year, we're looking to bring in an education effort that is underpinned by a series of what we call shorter form credentials. You might know them as micro-credentials that deliver targeted knowledge specific to individual circumstances, and they will be available as work integrated learning options. And so a key part of our strategy here is to make sure we're aligned with the graduate programs of the major mining companies, who will be able to look to these students as people they'll be able to bring into their graduate programs at the end of 4 years. And in our discussions, we've been speaking about how these shorter form credentials can support their first year of learning, where they pick up, I guess, the foundation knowledge at a deeper level than that presented in the undergraduate program, and they apply it in their work and of course reflect on it. University education's all about rigour and discipline, and so we're still working out the mechanisms we will have for achieving that. But there's been a very strong receipt of this idea. And the way in which this would be conducted is this 5th year is we'd look to have students conduct a project on site as part of their 8 or half of their 5th year. This project would be an engineering practice project. So they'd work either as part of a team or individually on a project that is relevant to their sponsoring company. And we would work with them in the supervision along with that site to ensure that the outcome is of value and that the students' learning is there. And then the balance of that year would be taken in these shorter form credentials, which we imagine will be delivered in an adult learning mode. This model has some other advantages which will help support both the industry and the university in sustaining its activities. And that is individuals, we're looking to design these shorter form credentials so that they can be taken in isolation. So somebody coming from a cognate discipline who doesn't have any direct knowledge of mining but wishes perhaps to understand the foundations of surveying, or perhaps is looking to build knowledge in ventilation or any number of other areas, can take these hopefully in isolation. There will be some prerequisites they need to meet, and they will be able to stack these up into a credential such as a graduate certificate, and we will be able to package them up by taking the subjects from the major in mining along with this 5th year and packaging it as a Master of Mining Engineering, or it will be hopefully in a suite of professional programs. So the Master of Mining Engineering Master of Professional Engineering in Mining Engineering, but that is pending approval. And I'm not sure about the interest in this for the domestic market, although that's still to be tested, but we think there is interest in this from the overseas market, and that's an important part of our business, and so we need to consider it. So there are a number of features of this program, and we can talk to them, but the key principle that I think everyone agrees with is that you learn by doing stuff much more deeply than you learn by listening to someone talk about it, except today where you're learning a whole lot from my talk. And so, it's that Benjamin Franklin quote, tell me and I forget, teach me and I remember, involve me and I learn. And we're really looking for that close integration. It's a practical discipline. Engineering is a practical discipline. We want our graduates to be the most sought after. And part of that is that they've got the wherewithal to actually be functional in the industry from day one and know how to make the right career steps. And so this is all part of our thinking. The company-sponsored cadetships that we see as an important part of achieving that. And so we're looking to do that. And many companies see this as well. Companies like Newcrest and Downer and a number of others have explicitly raised. Jallenbar, I guess, was another who raised it, have explicitly raised that they want to do this. And so we think that, a student taking that stream of courses through their program gets an opportunity to do this, and then they can step into the master's year. And I think that would be, if we can make this work, this is going to be a very, very powerful tool for bringing knowledge to the industry. What's in the programs? Gosh, that's not good, is it? Something's happened with formatting there. But essentially, we've got over here, we've got our courses, our 6 courses. We call them the Gang of 6. And then we move into this work integrated learning mode, and student programs will be tailored. So we've sort of atomised it a little bit, and students will be required to meet a certain number of, I guess, points to qualify, but they will have opportunity to specialise as appropriate to the work they're doing. And there's a lot of detail here. But either they'll elect to something in surface mining or underground mining and a set of short form credentials around that. They'll look at short cycle control. This is our strawman model, and I'm keen to take feedback on this today. Short term control. So mine, short term mine planning essentially, and sort of stuff they often do as graduates. They enter into the planning office and undertake work in planning for the short term, or they move into the blast team and they work with them, or they do some combination of these things. Value chain optimization, and then sustainability and mine closure. So we're looking at these as themes. So the surface mining or underground mining being one of, they need to choose one of those, and then they need to build up a set of, and choose a minimum number of short form credentials from within their choice, and then they move into, they need to also look at planning, short-term control, value chain optimization and sustainability. And that's a different perspective on them, which perhaps is more readable than the previous slide. And we can return to these, but I don't intend to cover them in all of their detail, but rather convey the structure. Now, we've not finalised on this. We're just trying to get our head around it and put forward a credible straw man that can be, can be addressed by the industry to see whether it's what they think is appropriate. We've taken on to look at this with BHP in particular and see what we're proposing maps against what they are interested in terms of their graduates. They had Deloitte build up, I guess, a career map and map out all the skills they need across all of their employees, across various stages of their careers. And we're quite pleased that we can fill this and find good opportunities for work integrated learning. So I'll just summarise where we're at. We've worked hard to identify a structure and organisation for mining engineering, and we think this model will actually strengthen UQ's capability to deliver graduates to the sector, because we're opening up the opportunity for more of our disciplines to take a major in mining. I think this is very important, and it's getting very good feedback from students. It's going to be attractive to undergraduate engineering students because it meets their request for flexibility. They were quite plain to us that they didn't want to lock themselves into a profession that they were concerned may not have all of the opportunity that they could get from other choices. And we've tried not to force them to make early decisions. We know that this group come from school with a set of set of views and philosophies and attitudes that isn't aligned with the sector. But as they mature through their engineering programs, they do become more understanding of the value and the importance of that sector. We're still committed to building depth with our mining in mining engineering from graduates, and that will be through the BE ME honours, and importantly that will be supported by the Commonwealth and of course the students themselves. Our structure is going to enable people who want to cross-skill or come from other areas to have access to formal university education in support of any transition they want to make into the resources sector. And we see there being a demand for this. See there being a demand for this from within the sector already, and a demand from outside the sector, people who are saying, you know, I'd like to give this a go. How can I do it without going back and doing a 4-year undergraduate degree and then a 1-year master's on top of it? Can I make a commitment for a few months and build up some specific credentials that, together with my existing attributes, will allow me to be competitive for roles. And importantly, these will be stackable into qualifications, so graduate certificates, Master of Professional Engineering, which would have accreditation from Engineers Australia and AusIMM, and this is recognition from AusIMM, and this of course is for us important to trying to find markets of international talent into mining. So where's next? It's only going to work if we've got really good engagement with the industry. We've been trying to run a 2-day facilitated workshop to develop up the detail. Sadly, scheduling's proven difficult with COVID restrictions. The university's got some very tight constraints, both on and off campus for us, which have proven difficult, and finding venues that will allow us to do this in a way that allows Zoom to be used. But at that workshop, we're looking to establish what topics should be the focus of the short form credentials. We're starting to firm up on a straw man for that, but we need to, I think, go back and look at how we map against what the industry wants for its graduates and what he wants to do with them in graduate program years. And I mentioned BHP had provided us with some excellent material to help us do that, and we're pleased with where we're landing there. We're also being guided by it, but of course it's not just about what BHP wants, it's much broader than that. We want to know if this idea can find alignment with graduate programs run by mining companies, and a lot of our consultation has been with sort of groups comprising chief mining engineers for the companies where we can access them, or the most senior mining engineer we can access, and the most senior HR person or the HR person responsible for graduate recruitment, to just discuss what the barriers and constraints are after describing what we're looking to do. We need, I think, to still understand better the barriers that we need to overcome to ensure this is sustainable. So we're not looking for a 1 or 2 year transformation. We're looking for a real, I guess, once every 20 to 50 year change. We've got to work out how those BME students need to be compensated. They enter programs with students who have done the same level of education as them, you know, but they're still in a student mode. What's the fair and equitable way to do it, and what might that be across the whole industry? And there are countless other questions. So, you know, we're open to getting as many people involved in this planning as we can. We of course need to confirm the dates, and as I said, that's proven a little bit unlikely, but at the moment it looks like January 2021. And I've given an email address there. I'll pass on to Andrew these slides, and you can circulate them around. So that ends my talk. I'm not sure how many COVID days it went for, but I hope it wasn't. I hope it was interesting. And here's a chance to ask some questions. Yes. Yeah.
Try and hone in just a couple. But how do you see a sort of gateway from geoscience into a major mining engineering or
It's,
where the other spectrum?
it's a really good question, and one we've looked at while we were. Okay, thanks, Andrew. The question was, have we considered, or have we identified a pathway for students coming from, say, geosciences or geology or other disciplines into, I guess, a mining engineering major? And the answer is they'll need to do still the Bachelor of Engineering if they're going to go through an undergraduate pathway. But the university offers cross-credit and dual degrees, so it's possible for them to leverage their science degree with an engineering degree, but it will require another year of study on top of what's there. We've talked about it a lot. It seems to be something that is achievable. It's going to depend on in this case, the passion of the student. There's another pathway though, and I think this is maybe the more pragmatic for those who have already graduated. So I often tease Alice by saying I can always tell a geologist, I just can't tell them very much. And and your reply to that is good. All in fun, of course. But this is something that Alice has pushed for very hard right from the start, because through her years in industry, she saw many people taking this pathway informally, and to be able to give them formal education here. So Alice, do you want to speak to this at all? Yes, I thought halfway through I should have invited you up here because there are some people on Zoom. But Alice basically said, if I paraphrase, the advantage or an advantage of this model is it will allow people working in the industry to top up their skills in specific areas. So Alice, as a geologist, used the example of needing to understand mine ventilation to properly perform some of the roles that she filled while she was with MIM. And this program will, through a short form credential or a suite of them, in the case of ventilation, help build the foundation knowledge, which will be then a point for transition, if we're talking about ventilation, into the sort of more formal process for being recognised as a ventilation officer.
Josh, thanks for that. I'm curious to know what the degrees will be. Is that better for your students going forward? And secondly, how do you marketing this degree through across 11 or 12 other campuses?
Yep. So do you mean what is the cost to a student?
That's right.
It will depend on the student, and it will depend on whether they're currently enrolled or whether they're enrolled from next year. The cost overall is around $40,000 per year. per annum, per year. Now that cost is met in part by the Commonwealth for Commonwealth supported degrees. So you need to be a domestic student to access that. And in part by a deferred payment that students make, which is called HEX. And from next year, that balance shifts. It'll be more like 60% paid for by the student and 40% paid for by the Commonwealth. If you're an international student, you will pay that full rate. Now that then is subject, the amount of that we see at the school is only a very small fraction of that, because there's all of the operating. University has a lake and it has ducks, a whole flock of pro-vice chancellors and various others, but we will get around about 20% of that coming through to us. And that's one of our problems, you know, that we just don't have enough to operate and do things that we've been doing in the past. So second part of the question, can you repeat that? Can you repeat the second part?
Second part's just how's the market?
Yep. Yep. So that's a complex situation. The university has something called the Future Students Program, which is a program run by a communication and marketing group, which lays out the broad structure of options for students, and among those will be these plans. We have at the faculty level outreach programs, so going out to schools and explaining what we do, and we have a team of around about 8 or 9, I think, people who spend their time, you know, going out and trying to bring connections to students and bringing them into university, where the QMEA academies will come and visit us over the summer, so they'll bring in students to the university, and we'll send people out there at various times, typically a member of the team and some academics to talk to them, or undergraduate students or postgraduate students or others. We market through our open day, which gives an experience at the university. This year a virtual experience, but more generally, more usually a general one. So there's a whole suite of marketing. We also have a student society called Mama, and many of you were members of Mama. Do you remember Mama? I'm on record saying Mama's my favourite student society because they are the ones who have the best parties, but their parties are always focused around the industry. And I think, Andrew, you go to the parties, don't you? Yeah. So they bring in every week, they have a speaker, and the speaker talks to the group of students who want to participate. They don't necessarily, just any students, I think, come in, and then followed by a barbecue afterwards. And so that's proving to be an effective form of marketing. One of our issues with students in the program is actually rounding them up. A lot of people say, you know, if you could just give me an hour with them, I could change their minds. And my only response to this is, well, we've tried it and they didn't come, and finding them and rounding them up and getting them to come is almost impossible. You get a very small cohort. They're very standoffish. So at the moment, internally, we're marketing the existing program to our first years. That's the one they'll enter to, and students who will join us from next year, we're marketing the new model too. I'll take one at the back.
Yeah, Marcus. Just a question on the shortfall courses. What's the delivery format? Is it going to change with current situations, COVID, remote learning?
Yeah. The question was, how will shortfalls be delivered? We're looking at a number of modules. In some cases, it will be in the sort of executive style education that is used by say the graduate school to deliver the MBA and similar. And so that can typically include some online delivery or some evening type classes for people who are working, or intensive efforts at the university, so week-long efforts, and they all have their advantages and disadvantages. We're imagining that a key part of this is going to be the university providing some really authentic learning assets that set down the principles and of a short form credential topic, and then on top of that a sort of alignment with if they're placed in companies while doing this study, with a mentor in the company to support them in practicing, I guess, that aspect of the curriculum, and that is why we really are looking for to tailor your own degree in the 5th year, for the reason that everybody's opportunities will be very different depending on where they're working, but there's still going to be common knowledge that builds to them. We think that it's going to be a challenge, and it's going to take a few tries to get it right, I'd say. So our plan is, this won't formally come online for a few years now. Our new first would come in, they'll be the first that are eligible for this. It'll be 4 years after they come in. So, but we're hoping to target it a little bit and do a number of trial runs, hopefully get the curriculum up in practice and see how it works. Yes, down the end. Yep. And we think there's an opportunity actually to push that professional year up into what is the year, if we can get enough other material and then they come back and maybe do another year. But it's fraught with complexities. Students will. What we've found is students design their own study plans. We put a lot of work into thinking about how things connect, and you need to do this before that, and they don't follow that advice at all. They just do what they want, and that's fine. I think provided you've got enough to carry you through the different levels of learning you need to do at each stage, that's perfectly fine. I think there was an analysis of 1,020 graduates. I'm making these numbers up, but they'll be ballpark right. There were 1,019 different study plans that students had followed. I think you might remember that one was produced. I think you were at that meeting. Yeah. So it's not exactly those numbers, but it's in that sort of order. Essentially, there is no common study plan for students. Yes. So there won't be, for these students, the students electing into the ME do not do a thesis in their 4th year. The students doing the BEME will not do a thesis in their 4th year. They will do a 8-unit project, twice the size of a typical thesis, in their final year in industry. Yes. If they're doing the BE, they'll still do a thesis. So the BE with the major, they'll still do a thesis, but if they do the BEME, they won't. They'll do that industry-based placement project. Yes.
Just wondering how involved industry is actually piecing together the content of those short.
Yeah, so we're trying to get industry very involved, and we're, as I've noted in that final bullet point, we're looking to invite you to participate in a workshop to share views.
So
Yeah.
Because I guess there's
Yeah.
a lot of core content that
So the exercise we're doing at the moment is taking the capability work that Jill Terry and BHP has developed up in conjunction with Deloitte or someone, and mapping our curriculum across specifically to BHP, I guess, job attributes, task attributes, I think they're called, within that framework, and trying to understand whether we've got alignment there. That's partly to ensure that we've got a pathway with BHP to make a case for engagement in the graduate program. But of course, it's more than that. Newcrest and Rio and Anglo and all the others are similarly. So there's a set of work in that. We're happy with how we line up with BHP, and we're going to try to work individually with the companies, but also seek more broader advice from everyone as well. Yes.
Brett Holman, Outsource Institute. So where with that system, so pathways from trade through, with the hesitance of first year to go into the mining, see that that is a stronger opportunity to bring people straight into the mining engineering, because they've already been working on that field. They know the ins and outs of it. Are they going to be more likely to be a stronger candidate moving forward?
I hope so. Oh, look, we've talked about this, Brett, and you know, there's the key issue that the university always faces with bringing students from different pathways in. If they're coming in through our first year, they must come through QTAC regardless. And we set out, as do all of the other universities, a set of requirements, and people meet them. Their trade qualification gives them very strong advantage in that. It raises their effective ATAR, but they still need to meet the prerequisites, and these are maths and English and chemistry at the. Yeah. Yeah. So I think there'll be two entry points here. There'll be an entry point provided they meet the prerequisites and their advanced diploma has given them the maths and so forth that they need, which is often the issue for the vet students. There'll be an opportunity, as there exists now, to enter in at the second or third year level, depending on their qualification. There'll also be an opportunity for them to enter in to this, I guess, specific shorter form credential, if this helps them. But they won't be able to build a graduate certificate unless they've completed an undergraduate qualification. Very complex space, but I think it's about understanding the pathways. Yes, Andrew. Oh, no, there is. I mean, the idea is that when you go into that fifth year, you're going to be either surface or underground, and that's consistent with most of the graduate programs. And if you enter into the undergraduate pathway, there will be ventilation, short form credentials, and there'll be block caving short form credentials and other matters. And in surface, there'll still similarly be credentials around, occupational hygiene in surface mines, dust management and things. But you're going to have to choose one or two of them. The argument may have been to need to come back. If you decide you don't like surface mining and you really want to do underground mining, you may, well, I'll put it in a positive sense, you can come back and you can do those ones for mining and build them up as a shorter form credential. Yes.
I was just going to say, have you had anything to do with any of the other MBA universities, such as or Boston, to see if they're trying to do something more?
Well, yes, we have, and we communicate with them regularly. We've explained our plan to them. and they're self-governing and they're going different ways. I think UNSW is sticking really with the curriculum they had. I'm not so sure about Curtin. They sometimes say they are, sometimes say they're not. So I need to really understand that a bit more. But you're looking like you want to say something else. You're leaning over. No, okay. So yeah, look, we're trying to be communicative and get feedback from them as well and share them on. And there's a sort of national committee that's been set up to be the vehicle for discussing this and to be the vehicle for finding the good collaborations that we had under him. Yes.
So we spoke a lot about mining, that's great. So if you're doing a major of mining, and we're sharing this as an overhaul for the whole school year, so there must be a lot of other majors that you can participate in. And do you see a world that students are coming out with 2 or 3 majors that let's just do another year and another year?
No, they can do a major.
They can do a major. Well, answer this, are there other majors on offer?
Many. Okay, so this is not just something we're doing in the school, this is something we're doing across the entire Faculty of Engineering. So there are 4 schools of engineering and we're all designing into this. So civil engineering will have, for example, the Bachelor of Engineering in Civil Engineering with a major in mining or in geotechnical engineering or in fire safety or in a number of other topics which are escaping me now. Electrical engineering will have software engineering major. For mechanical engineering, we'll have aerospace, materials, manufacturing, fire safety, mining. There's a suite of them. So, you know, it makes sense. You know, as students progress in their studies, they specialise more and more to their interests. You know, they need to get foundation knowledge and then it sort of breaks up into smaller groups and then within those smaller groups. Absolutely, yes. Yep. Yep. So a graduate certificate does need to include a number of postgraduate courses, not just undergraduate courses, but you could pick up some of the courses. It's typically 8 units, so maybe 2 undergraduate, 2 postgrad. All right, Andrew's telling me I need to stop.
Sorry guys, just in the interest of time, it's coming 9 o'clock, so we'll finish up now. But we do want to give you a little bit of a gift for our appreciation. Thank you for coming down, and yeah. And also thank you Cormac and Alice, it's much appreciated. And as I said before, they've taken time out of their busy days to come down. They've got a conference on after this, so very much appreciated. I hope you guys will enjoy the conversation. I think, yeah, moving forward, I think they're very interested in getting industry involved. So if you want to send through questions or whatever it is, I'm happy to be the point of contact and pass them on or summarise it. Otherwise, yeah, we'll be sending out the slides, and a recording for this will also be coming out as well to everyone that registered. So we actually had about 100 people register, which is a really good turnout. So 50 register for attendance in person and 50 for webinar. So there's people across Australia that are, and internationals as well, actually, that are interested in seeing this. So very important conversation. Thank you. And thank you, everyone. I hope you enjoyed breakfast. Yeah, cheers.
I'm going to have to run off reasonably quick. Yeah.